Welcome everybody to our SD-WAN webinar. I'd really like to thank everyone for joining us. And today the webinar will be held, will be driven by Ronald. Ronald has over 25 years of networking experience and is really focused on SD-WAN adoption in South Africa. And then later on, we'll have a panel discussion, and we'll include Ronald from iTried, who has actually implemented SD-WAN in South Africa and understands it from a practical point of view. And in our panel as well is Justin from Comsol, who's also involved in providing links. Thank you, Ronald. Over to you.
Thanks, Kitesh. I'm going to start the initial slide deck around this webinar, which is basically an introduction into SD-WAN, about what it is not and what it is. So let's go into the brief overview of what Fusion Broadband South Africa is. So Fusion Broadband South Africa is a part of a greater company that is originated in Australia and has gone into the greater Asian market, including Indonesia, Malaysia, Philippines, and Singapore. Fusion has been around for over 10 years, and it's currently in its 8th generation of software. The number of managed service providers include at least 200, with at least 2,000 multi-site PWANs. There's also multiple voice customers, with a customer with over 3,500 sites. And the thing that we're extremely proud of is that in 2020, Fusion Broadband was the IBM Beacon Award winner for Outstanding Infrastructure Services Provider. Okay, basically what SD-WAN is not. So firstly, SD-WAN is not the renaming of firewall VPNs to become SD-WAN. SD-WAN is not about road warrior access. It's mostly about site connectivity, traditionally what a normal wide area network would be. It is not really about remote workers and singular instances. SD-WAN is not about making your Wi-Fi easier to use. It is not, Wi-Fi typically is not involved in the overall equation of SD-WAN except as an additional service. SD-WAN is not the automation of legacy networks. Legacy networks don't automatically become SD-WAN just because they're automated. SD-WAN is a different way of doing wide area networks from upfront. It isn't just taking what you had before and using that. For an example, the legacy ways of doing VPNs is based on IPsec technology, which was around when we were using Novell network servers and IBM token rings from before the turn of the century. So we've moved on for that. So it's a totally new way of looking at things and doing things. It's not a legacy. SD-WAN is not necessarily just a mesh network. Just because you've got a mesh network doesn't mean it's SD-WAN. It's a lot more than that. And SD-WAN is definitely not reactionary security. SD-WAN is a lot more focused on being proactive and not reactionary. So you aren't going to react to an event and then put a mitigation against it. You're going to try and prevent that event from happening from a security point of view. What is SD-WAN? Well, firstly, SD-WAN is about making your internet bulletproof. It is about catering for all types of connections across multiple ISPs and network operators. So in this instance, it would be fiber, fixed wireless, and sometimes even, although it isn't so much the case anymore, technologies like ADSL. LTE might be an option, but it's typically always a last resort, because for a business, you don't want your site to be running exclusively on LTE. You would like something that's more reliable. SD-WAN is definitely about the automation of the last mile provisioning. And what we mean by that is that it is effectively a more automated provisioning. You aren't going to wait days, weeks, or months for a last mile to be provisioned. It's going to be there in a couple of minutes. And the way we do upon that is relying on broadband networks that are available instantaneously, effectively, and as fast as the people can provision it. It isn't like you need a project plan with MPLS to get your links in place across multiple locations. With SD-WAN, secure communications is the default behavior. So SD-WANs are by default secure. Previously, before we got to the stage of implementing SD-WANs, wide area networks weren't inherently secure, and the mechanisms of securing them were an afterthought or bolt-on. Secure communications with SD-WAN is the default behavior. SD-WAN is also about making quality of service with crystal clear voice something that's workable. So you do not have quality of service that is not ingrained as part of SD-WAN. SD-WAN delivers quality of service in a bi-directional manner across broadband links. SD-WAN is all about enabling cloud services, and those cloud services can not only be your office cloud services, of which we've got typical examples of storage solutions or office solutions, or even ERP solutions or CRM. It's also those security services. You can now rely on security services that are cloud-based that protect your organization. The next thing about it is that SD-WAN provides all related auxiliary services that connect you to the internet and make that rock solid. This includes something like name services. Your name services need to be rock solid. You do not necessarily have to have a branch network to use SD-WAN. You can be a single site to use SD-WAN, but many people with branch networks use SD-WAN to implement a branch network. So let's go into if there is a magic source available from Silicon Valley that actually solves all of the SD-WAN problems. And like most things, just because a vendor has got something that's marketed and that is proprietary doesn't necessarily mean it meets the business objectives of what we are looking for. And also, significant innovation has been with products that have been driven by open source efforts, and something like the Linux kernel is a very good example. So the measure of how a solution is delivered is how those services get implemented and utilized. It's not about a box drop anymore. And typically, SD-WAN will never be a good solution if it is packaged as a box drop by a vendor. SD-WAN is one of those services like any other cloud services where it's the overall holistic solution that is important, not just the product and the box. The other thing that we need to remember is that in the latest security problems that we've had, every firewall and vendor out there has had its security compromised either by ransomware intrusion or hacks. So the latest examples have been the Exchange problems and the problems with SolarGate, and even the problems with the VPNs being compromised from all the major vendors across the spectrum. So if a firewall is not SD-WAN, what is it? So at its basic level, a firewall just does NAT and port forwarding, which is an extremely important ability required for you to operate with a private network and your connection to the internet. Most broadband routers nowadays actually do have a firewall. It's not something that is enterprise specifically, and functionally they're the same. The next generation ones added the ability to do signature-based scanning, but typically that's not really that much of an enhancement because mostly people have gone to encrypted traffic, which has negated to a large extent the ability of next generation firewalls to be a box solution. Firewalls have also been vulnerable, especially on the VPNs. During the past year and a half, every VPN from every major firewall has been compromised with some viability. And at this moment in time, the top exploit, as mentioned by the FBI, are those VPNs being exploited in the wild, mostly because the firewalls haven't been updated with code and users haven't actually addressed the problem. So the actual, at this moment in time, that although a fix has been published, it still remains the biggest problem that has been recorded by the authorities. Firewalls are also not the only thing that protects you as far as security is concerned. It is a very necessary cog, but it is not the only cog that a person has. So what are these many cogs that you have in a network? Well, firstly, when you deploy firewalls and you put them in a carpet bombing strategy where you deploy them at every location, each one of those needs to have a babysitter, and it doesn't always work out as the best possible strategy. In the pandemic, one thing we learned is that if a country wants to secure itself, it has to limit its access on its borders, maybe to a single airport entry point or a minimum entry points. If it has got multiple sea or land entry points as well, the probability of people coming into the country during that pandemic and spreading it further is a lot higher. So it is exactly the same when you deploy firewalls. If you've got a central firewall where you choke people and connections to, you've got a lot easier ability to manage the ingress into the network and the security of that network instead of having multiple points across the whole network. As an example, firewalls have allowed the probability of the exchange servers being compromised in the latest security vulnerabilities that have been released. And in that context, a network-based firewall didn't actually help. You actually had to go to something more specific called a web application firewall, which actually ran on the host or in front of the host to make it more secure. SD-WAN, in this whole new cog, it changes the way people look at things, and it makes the security a different scenario in that people are secure by default, and it's usually called zero trust networking, where you're evaluated upon a score on the source of that interaction, and it's allowed based upon whether that is going to be a secure communication or not. So the difference now where we had previously is we would upfront determine what our firewall rules would be. Nowadays, we're moving to a place of constant monitoring where we determine what the score is of what we're going to do and whether we are going to allow it. And that's essentially how we get to zero trust networking, where we're only going to go and interact with something that we trust. So the real SD-WAN use case is about why networks fail, and networks will fail regardless about what you do. They are very complex chains, and networks are very difficult, and they're constructed like Lego sets. And I'll explain in detail about what that means. If we look at the fiber last mile, you'll see that there are multiple chains in the actual fiber last mile. The client goes through the infrastructure provider, his equipment on site, the equipment on the curb, the equipment on the backhaul to the data center. There's actually interconnections within the data center. Then there's connections from the data center into the internet. Along that chain, there is a probability of any failure along those points will lead to an outage. A lot of people that I speak to sort of get the impression that there's like, you connect yourself to the internet and it's a singular connection. It can be upwards of a dozen to more than 24 connections before you actually get to the internet, and any one of them can fail at any moment in time. The fixed wireless is very similar. The only difference is that instead of having fiber ONTs and curb boxes, you now have got a client radio and a base station, which runs the last mile over wireless instead of fiber. But you typically have the same number of connections. So how do we actually solve this problem of when you have a failure? Because you're going to have a failure, and you have a failure in a very complex system that's going to happen most likely whenever you utilize the internet. It's not going to be up 100% of the time. You actually need to get two. So we know with jet engines, you'll never climb into an aeroplane that doesn't have two jet engines. We all know that an aeroplane can fly on one jet engine. So if we have a similar situation with SD-WAN, which we have with jet planes of two jet engines, we'll meet the business requirements of having performance, reliability, security, and the management which comes with it. How do we do this two engines on a jet plane in SD-WAN? Well, first of all, we have a SD-WAN CPE, that knows that it's got two paths. In this example here, there's a fiber last mile chain and a fixed wireless last mile chain. And that CPE can utilize any one of those. In this example, I've got path A and path B. So when there's a failure on the fiber, it will automatically use the fixed wireless path. And in that manner, we can ensure better uptime. So fixed wireless is a very good example to use with fiber last mile, because, for example, with fiber last mile, if you use just fiber last mile and you've got two fibers coming into your office park, they might also use the same conduit, the same road. And if a trench digger comes in and pulls out the fiber, it might take out both. With fixed wireless, you can at least mitigate that problem of a fiber being cut within the last mile, because typically the fixed wireless last mile typically goes about 4 kilometers away to the nearest base station. SD-WAN has got many attributes. I'm not going to talk about all of them. It's got more than 20 attributes. Are all of them required? No, not necessary. It all depends upon your business requirement, and your business requirement might only require one or two of those attributes. So when you're looking at SD-WAN, you need to say, what are you trying to solve? Are you trying to make it more reliable? Are you trying to make your internet perform faster to the cloud? You've got to know what you want to do. You do not require all of them. You implement those that actually meet the business requirements. What are the use cases for the SD-WAN, and what are these business requirements that you usually have? The one that is very common is MPLS migration. And it's very common from a business point of view, because MPLS is expensive and SD-WAN comparably is less than half the cost on a return on investment over a year period than MPLS. So it's very easy to actually justify SD-WAN from a cost perspective by an MPLS migration. The next thing about it is that if you've got something that is on-prem, for example, if you are providing services on-prem, like on-prem servers or on-prem VPNs, and you want a bulletproof access to it that never goes down, you can do that with SD-WAN. From an ISP, you can actually implement managed last miles for customers. So one of the benefits of SD-WAN is that you get total visibility on what's happening across multiple paths, immaterial of what is happening in the underlying medium. And that allows a person to, when a problem occurs, to resolve it faster, because you know precisely what's happening, because you know that a fiber link has gone down, because you can see the fiber link has gone down from the telemetry that comes over the fixed wireless connection, as an example. You can utilize SD-WAN for rock solid internet access and threat mitigation, where you are actually proactively mitigating security threats. The next very good example, especially in this area of pandemic, where people have made office spaces smaller and relying on other works of medium like work from home, or another example is co-location, which is the hybrid model where people share office space in a co-location environment. SD-WAN is perfect to actually implement in those co-location environments. Cloud acceleration is another example. So instead of having on-prem file servers, you might use Dropbox or OneDrive, and you might, especially in a office environment, you want quicker access to those and not degraded access, which you might do because it's further away, as in on-prem. SD-WAN also solves a lot of problem sites where there are connectivity issues, and it typically solves problems where previous technologies wouldn't just solve it by itself, but SD-WAN is able to run where others can't. Finally, if you're setting up a branch network with a private WAN, this is any type of branch network you can now run across the internet in a secure manner. That is now completing my slide deck about the explanation of SD-WAN. We are now going to go into a brief discussion with Ronald from iTribe and Justin from Comsol, and also Jen from Australia. And then we're going to take questions from the audience. If you can now also, if you've got any questions, just type them in the chat window and we'll look at them and we'll get to answer them.
Well, thank you very much, Ronald, for that presentation and taking everyone through SD-WAN. Every time I listen to the presentation, I learn something more.